A warm welcome from my side. My name is Moritz. For those of you who don't know me, and you are right here at the Hanseatic Blockchain Institute. And we have been in place since 2017 when a group of Hamburg-based blockchain entrepreneurs felt that this was be a good point in time to establish a association, einen deutschen Verein. So we are not a kind of lobby organization. We just primarily intend to communicate, to learn, and to introduce people to the possibilities of blockchain or decentralized business models. As part of our kind of mission, we do this Demoor Blockchain Monday, e.g. not every Monday, which we did in the very beginning, but we do it on a monthly basis now, sometimes virtual as today, sometimes as a real life event here in Hamburg. Well, we talk, we discuss, and we introduce new concepts of using decentralized technology. And with that, I would just briefly want to say we are a German association. Everybody who is interested to support us can become a member, which is currently available at €50 per year, which is quite cheap. And if someone is interested in supporting us content-wise, we recently did a study on the behalf of the German Ministry of Economy, which was called Kann Deutschland Blockchain? So how well is Germany positioned in blockchain and so on. So we are quite active in other things, but apart from that, the Blockchain Monday used to be the kind of most relevant thing we do. And I'm very happy to have Thomas with us today, who's working for a company that is domiciled here in Hamburg as well, called Impossible Cloud. And yeah, with that, we want to talk about this new concept of decentralized storage, somehow being in competition to very centralized players like Amazon and so on, and offering an alternative which is based on a decentralized structure. I hope this in principle is right. So everybody from the audience, please feel free to make it as interactive as possible, ideally by using the Q&A button if you have any questions or remarks, and then we will push them towards Thomas. And yeah, with that, great to have you here. And maybe before we enter into the story, if you can just give us a short intro on your background, and particularly when you first discovered decentralized or blockchain-based technology. So when was your first time, so to say, when you discovered this technology?
Yes, I think maybe first on the last question, I think actively working on the space was only a year ago when I joined Impossible Cloud. Yeah. So I'm fairly new to the ecosystem. I think before, of course, it's a space that you follow if you're. I was in storage systems before, and so you see these things like Filecoin come up, and you read the white papers, and I held some certain Ethereum, for instance, Bitcoin, those kind of things. But actively working, it's about 1 year now. All right. I've been learning a lot from the people in the team, and I think my previous experience, I really come from this cloud space, from the private cloud space, where I spent about 10 years building private cloud systems. Joined after my PhD in computer science, I joined a startup in Belgium, in Ghent, called Amplidata. We were basically the ones that pioneered erasure coding, distributed storage across multiple nodes in a super efficient way into the private cloud setups, where before they were using multiple copies of the data. So that was a more cost-effective way of storing data. And we got acquired by Western Digital, the hard disk vendor.
All right. Okay.
For what the media reported to be around 300 million euros. So spent 5 years at Western Digital, building out the platform, scaled the team from the original 20 people in Belgium to over 500 people across Belgium, California, Colorado Springs, India. So had a really big team working on S3 compatible object storage systems.
All right.
So working on private clouds, going into a lot of data centers, customer data centers, living and seeing the challenges there. People only have 2 data centers and they actually would need 3 to get a better protection level, a better failure resilience, that if one data center goes down, that you basically can continue running the system with the remaining ones. And so you need at least 3 data centers for that. And so a lot of our customers did not have that opportunity yet. And so they were struggling to get the best architecture. Then after 5 years, Western Digital sold the business. They exited all of their software products. They focused back again on core devices only. And we got sold to Quantum, which is the tape library company. Tape libraries, people think about, it's very old. Think about the technology in cassettes. It's basically the cheapest way to store data for very long periods of time. But it's not a technology. Actually, all the hyperscalers, Amazon, Microsoft, Google, Tencent, Baidu, they all have these colder tiers, typically called Glacier or Archive or something like that. And so those are involved with storing data for longer periods of time, and they also buy a lot of tape libraries. And so at Quantum, we basically built this cold tier at the end of the system. And then I met Kai and Christian, and I had it on my bucket list to work on a public cloud at some point in time. It was really traveling the world, visiting customers, visiting all these data centers. I had to physically go there. These things are not connected to the internet. It's really private, bigger 150 petabyte systems for single customers that they would not open up to the world. And so it was very challenging to service them. And I really wanted to work on a public cloud, and then met Kai and Christian, who had this very bold vision to build a decentralized cloud from Europe, from an European entity, which has obvious geopolitical interesting angles, especially right now. Recently, that has become more and more of a thing. And so really got swept away by their bold long-term vision and their willingness to innovate and build this very challenging thing. This is going to be a many year project, just like any challenging startup should be, right? Otherwise, the problem you're trying to tackle is not big enough.
All right, I think with that, maybe you start with your presentation to explain to us what it is all about and how it essentially works.
Need to request sharing.
1 sec. Now you should be able to do that.
Yes. Let's see. Does this look okay on your side?
This is the web thing I see. It's not full screen, but I see it. You might want to go into full screen mode, but no worries. It's next to the Zoom. Go down, and then.
Oh wait.
And then on the right-hand side, yes.
Oh, yep. There we go.
But now you are. Okay. We can see it.
Does this work?
Yep.
Cool. So Impossible Cloud Network, the decentralized internet infrastructure layer. So I'll start with a small product overview, and then I'll talk about how the company got here at this point, and then there will be plenty of time for Q&A. Basically, really the goal is how can we build a decentralized cloud in contrast to the current, I would say, oligopoly, where there's a couple of very big players that completely dominate the market. And so obviously you need hardware, right? The cloud is built on this hardware resource layer that you see at the bottom, where we have an ecosystem of hardware providers, people who contribute hardware in tier 2, tier 3, and above data centers, so that there's sufficient quality, so that we can build enterprise application stacks on top. So that's the first, I think, part, that people contribute hardware, but it is today that is restricted to enterprise use cases, enterprise grade hardware, and enterprise data centers. I think maybe later in the future we could open it up to different types of also consumer grade hardware, but that's currently not the case. But the protocol, of course, could allow that in the future. And then at the top you have the application layer, which is basically projects wanting to offer services to end users. And so you could think about the object storage service, you can think about the compute service. The hyperscalers have, I think, 100, 200 different services that they have built on top, and that they offer out to their end users. And so here it's also we want to create an ecosystem of, we're not going to build this all ourselves. The hyperscalers have a 20-year head start. If you just try to repeat their playbook, here there's a really, really rich ecosystem of projects, both Web 3 and Web 2, that basically can build on top of our infrastructure. And of course, these parties are the builders that want to build applications, and the people offering the hardware in the hardware layer and the data centers, they are not, they are decentralized, they don't know each other. And so how can we operate in a trustless environment where we guarantee the quality of the network? And that's of course where the protocol comes in, and then where also the Web3 aspects. That's one of the advantages, one of the reasons this is a Web3 project, is to have that layer. And so we're basically trying to have a globally distributed pool of diverse hardware resources with enough performance to serve enterprise use cases. And then the protocol sitting on top as an open service stack, and as a verification network to secure and guarantee the network quality and robustness, and to have transparent verifiability of the hardware resources, that actually people are really providing what they claim to be providing, and that we basically can validate quality, location, availability, and then on top of that, and I will talk a little bit about that, I think an ecosystem of pluggable proofs where different application layer participants can plug in their own set of verifications that serve their use case. And so the application layer books capacity from the protocol. The protocol secures a set of hardware resources and then offers that up to the application layer and the application layer project. That would, for them, the end-to-end experience is similar to renting a server on Hetzner or using an Amazon service. That's basically the core of the current state of where the project is.
Okay.
And so, of course, a lot of the growth is in these ecosystems, both on the application layer side, where all these projects building on top, as well as on the hardware side, where today we're focused really on storage because that's where we started, and we'll explain why, to add more, to add GPU, compute, networking. Again, many types of hardware will be needed if we want to fully serve the 140 plus services that, for instance, somebody like Amazon has. So you need a diverse set of hardware. And so these are two ecosystems, two communities that we are now growing to basically enhance the capabilities of the product. So the goal is to build a multi-service platform, not many use cases, performance and compliance, and focus really on enterprise end users. Maybe first a little bit of backstory. How did we get here? Of course, the cloud is a $3 trillion opportunity, growing very, very fast. I think the recent AI craze is another example of, again, another step level function in the growth. New applications and new use cases keep on coming up. And so the cloud has seen tremendous growth. And I think there's that will not slow down in the next couple of years, next 5 to 10 years, cloud adoption will only grow. And so that's basically also where the name comes from. Do you believe it's impossible to build a cloud to basically challenge these hyperscalers, somebody like Amazon, who has been building for 20 years? Can we still challenge that? And so, of course, definitely Bitcoin has proven that networks of this scale can emerge. And the computational power of Bitcoin is many exahashes. And it's way more than any supercomputer in the world. It's also way more than any of these hyperscalers have in their. There's more compute in Bitcoin than there is in Google or in Amazon So that really has proven the point that it's possible to basically scale a hardware network, a physical hardware network that outgrows these hyperscalers. Of course, it matured over time, right? It started with consumers, people just running it on their home machine, and then it professionalized, and then now I think we're in a completely different world in terms of the hardware that's required here. But that's also a very interesting thing, how you see that, how this ecosystem can professionalize. And so we are prepared to scale in a similar way, and so to get similar adoption as the Web2 hyperscalers. But of course, it will take time, and we will, of course, need to build this ecosystem. We will not completely do it by ourselves. And of course, there's a couple of projects that have made similar attempts. And I think what they've missed so far is that all of these consumers, or all of the customers here are very entrenched on the Web2 side as enterprise customers. And so for them, bridging the gap to Web3 and having them run on Web3 without them realizing they're on Web3 is a crucial part of the equation. And so if you look at the evolution, first there was, of course, Bitcoin. Arguably, that was the first DeepIn project. And so DeepIn is a decentralized physical infrastructure network. And there's a couple of different ones. For instance, Helium trying to build decentralized telecom providers. There's people trying to build decentralized cloud systems like we do. And there's a lot of, in the early stages, people mimicking that, but in a single use case. You see Filecoin there in phase 2, Akash, which is a compute project. They really focused on, okay, we can do the same thing that the Bitcoin network did. We can bootstrap this network. We use the token and all the nice ecosystem opportunities that the token creates to bootstrap the supply side of these networks. And so they focused on a single use case, bootstrap the supply side, and really didn't focus a lot on B2B enterprise customers. They said, we will build and they will come. And then, of course, after a couple of years, these projects have been around now for a while, we see that this adoption is not coming. And so people already a couple of years ago shifted more to demand focus, where trying to really focus on getting usage, and then focusing a lot of also the project resources on getting adoption, getting usage, and not only on scaling up supply. So trying to do that in a balanced way. And then DeepIn really took off. I think there's Messari tracks over 2,000 DeepIn projects now. I think there's 70 billion market cap between them. So it's really taken off. There's deepin VCs now focusing only on deepin. But what's important is that multiple of these things need to come together. And so we think that to really challenge the current hyperscalers, more is needed. And if you think about these centralized CSPs, cloud service providers, what they don't have is they don't have the advantages of Web3. Privacy, data sovereignty, security, that's all not built in. You have to trust, let's say, Microsoft. It's the Microsoft service, which is construed of Microsoft software running on Microsoft hardware and a Microsoft data center. You have to trust that they treat your data well and that they actually do what they claim, and there's no way for you to verify that. I think many Web3 projects have now shown the alternative, where there's verifiable proofs, there's privacy, data sovereignty, security, those things. Actually here, Web3 outperforms the Web2 traditional model. Here we have extra features which are given to us. The second thing that they don't have is the win-win opportunity in terms of building together. It's really, they capture all the value, and basically they squeeze end customers, they squeeze the channel, and eating up more and more of the ecosystem, eating up more and more of the ISVs, independent software providers that help them. And where with Web3, with the token, you have this natural ecosystem co-development. We will all get better together and we will all benefit. Those effects they don't have. But of course, and so then this first wave of deepins came up and they said, hey, we have these Web3 product advantages and we have the token to build an ecosystem. But they were very focused on a single use case. There's many, like there's probably multiple GPU only deepins. Akash is general compute, but you have things like A-tier, for instance, IO.net. So there's many players here, but all focusing on a narrow use case. Whereas these hyperscalers, the multi-service architecture is super important. It's just the convenience of you go there and they have any service that you need. And everybody needs storage and compute and networking. And so if you have to cobble together all these different players, for a normal enterprise end user, that's not feasible. I think the second thing that the first wave of deepins missed is that in order to bootstrap their networks, they say, hey, we're permissionless, anybody can join, but there was no quality gate. So to offer the services and the performance levels that you get from things like Amazon, you have to have enterprise-grade hardware, an enterprise data center with bespoke networking. You need to be close to the internet hub in Frankfurt with your multiple data centers forming an availability zone, running on the computers underneath people's desks. You will never ever build a system that can match the performance of and the general quality of something like Amazon or Google or Microsoft hyperscaler service. So there, we truly believe in the permissionless nature, that anybody who meets the quality bar can join, but there is, with the possible cloud, there is a quality bar. People need to meet certain requirements that we also verify and keep on verifying in order to be part of the network. And then the third, I think very big hole is that all the enterprise customers today are mainly in Web2. And so accessing the market is a very, very important thing. That how do you get customers to use your Web3 projects? And you need to spend a lot of your time there. And that's also what we did. So if you think about the ICN tech stack, really on top of that is a set of market access tools, which, for instance, for the object storage use case that we currently serve, it's simply a channel play. Like it's the same distributors, resellers, ISV, independent software vendors like backup systems like Veeam or Acronis, Comet Backup. So really these existing systems which speak the Amazon S3 API, which are sold through the channel. And so they are the customers and the people buying these tools, they just type in your endpoint as a backup location, hit enter, and the thing works. And for them, it's just a one-liner inside Veeam to configure the backup storage. So there you need to have seamless integration. You need to just work. And if people then need to acquire tokens, even some of these customers even legally cannot have those on their balance sheets. So it becomes very, very complex to do a pure play Web3 end-to-end story with these enterprise customers. And that's where we bridge the gap for these traditional enterprises. We accept fiat payments, and we basically make the conversion as Impossible Cloud, then the S3 service in front. We then convert to tokens and use that to access the protocol. And so for the end users, we're just a drop-in replacement for the Amazon S3 API. And so we started with storage. Why? Storage is probably one of the harder use cases. It has locality and data gravity. So if you have a couple of petabytes of data somewhere, it's not easy to move it somewhere else. And if you want to do compute on data, typically bringing the compute to the data is the way to go. And so if we first have the data, then we can from there build more and more services on top. That's the reasoning that the founders had. And so of course, that's also where my background comes in. I come from this storage background and initially focused a lot here. Of course, now that we're bootstrapping, building out the platform, now the scope is becoming way, way, way bigger. But that's how we started. And so the two is like scaling is not all by ourselves. We're not going to build 140 services by ourselves. We want to build an ecosystem of projects that all contribute parts of the solution, and that simply leverage the protocol to access the hardware, or to acquire hardware, but then each have their own specialization in terms of the software service that they offer.
Given the fact that Impossible Cloud acts as the Web3 tries to eliminate the intermediary, however, somehow Impossible Cloud acts as an intermediary between the storage providers on the one hand side and the customers on the other hand side, if I look at it from a kind of traditional point of view. So investing in hardware has never been an idea. From the very beginning, it was always just creating a platform that can be used for storage providers to be part of it. And was that easy to convince these storage providers, or how? So what's the crucial part in this process?
So yes, I think the people who built out these first networks, they were really longing for enterprise usage. How do we? There's all this usage out there, and why are we not getting enough of it? And so I think in the long run, indeed, the enterprise customers will directly integrate, and the intermediary will disappear. In terms of it will not be required anymore. It will be there for the people who want the ease of use, but others will directly access the Web3 system, the Web3 systems natively. So there's nothing stopping a Web3 native protocol from building on top of us and basically putting the tokens end-to-end also to the end consumer. It's simply to bootstrap. We have chosen to not take that approach. I mean, because most of the customers are still on the other side of the spectrum. We've chosen to first show a Web2 end-to-end use case. But of course, the Web3 ones will follow. We are actively working to also onboard Web3 builders on top of us that basically have tokens end-to-end. Of course, then they need to access the market access tools, are then not shared, they reach their community or their customers in a different way then, not through this traditional Web2 channel partner model.
Right.
So continuing, because the enterprise market is significantly larger, that's what we tried. You need this, as I said earlier, to get performance, you need quality in the hardware, and you need to leverage, we want to leverage Web3 to our advantage. Data sovereignty, data attestation, security are all not present in the same capacity in the current Web2 state of the art. This is really extra features you get on top by leveraging Web3, and then you get the entire ecosystem development as a bonus as well in Web3. So looking at it top to bottom, you can see here at the top, we built here the basically a vertical stack, but with our own market access tools and what I mentioned before. That's what Impossible Cloud is building, and then Impossible Cloud Network offers the protocol and the hardware resources to Impossible Cloud, but it will also offer, anybody can leverage Impossible Cloud Network. So not only our tool, you can build a Web3 native project on top of it, you can build a compute project on top of it. It doesn't have to be mimicking the use case that we chose to build out first. So
in terms of competition, one would assume, because choosing a storage provider is a very critical decision for every CTO, and I would fully accept if someone would say, okay, we go for the market leader, which presumably is AWS, well, being willing to try something else is tricky in the first place. And then I would assume that you need to have a standard, which is a kind of industry standard or whatever for your solution. And if I understand correctly, what Impossible Cloud now is offering has been entirely self-developed, or is this some kind of an existing standard that has just been adopted or applied?
So Impossible Cloud uses the protocol to book resources from Impossible Cloud Network, and then it gets these storage resources, and then it lays out its own software stack on top. And indeed, there's a combination of certain parts that we've written ourselves, for instance, on the S3 protocol layer, and then some open source tools that we're leveraging in combination with that. So it's a combination of certain key things of the system where we really can differentiate and build competitive advantages, that we build custom software. But that's really on the object storage use case, that the first service there that we've built on top of the network. For the network itself, is fully Web3 native, and is simply a way to acquire hardware resources. That's basically the other part of the project. And the S3 storage part is just the first proof point. Like, look, you can build interesting projects on top of the network.
Okay.
And so really this industry partnerships, that's all a focus for only this top market access tools, enterprise customers, storage, that's this Impossible Cloud thing, and then the network itself is bigger. And I think let me dive a little bit deeper into the network. I think this is the same slide. Maybe let's go here. And then focus on the team, and then do a little bit more of a deeper product deep dive. So if you look here, there's the two axes. One is how many services you have, and the other one is how decentral your infrastructure is. And so you see there's a ton of Web3 projects here, but all of them operate in isolation. their GPU or storage, and they have their own single use case. And then all the Web 2 players are at the bottom here. Some of them are single service. For instance, Backblaze Wasabi only offers storage. And then others like Amazon or Google or Microsoft offer a ton of services. And so for us, the goal is really to build a piece of the puzzle to integrate all of these different projects and to build an ecosystem there where we together offer one big cloud, where it's not these projects in isolation, but where we can basically link all these projects together and move to the top right corner so that we're not only decentralized and Web3 native, but we also together form this multi-service cloud where, because that's what end users want, they will not go from their single centralized IAM one user that works for all the services into basically a network of hundreds of different systems that they need to each individually integrate with and partner with. So I think maybe first, before we dive deeper into the project, a little bit about the team. I think Hamburg, so the company is based in Hamburg. Kai and Christian, the two founders, live in Hamburg. We're a hybrid company, which means that we come together one week per month in Hamburg, and then there's a set of the people who are remote who then go home for the remainder of the time. So I spend about 1/3 of my time in Hamburg and 2/3 of my time here over in Belgium. Kai and Christian before bootstrapped Good Game Studios, which was a gaming company, and that to more than $1 billion of revenue, they did a reverse IPO to the NASDAQ and had over 1,400 employees there. And they were, to run their games, they were paying hundreds of millions of dollars to the cloud providers to basically run that. And so that's where I think the little seed started. I think Kai has talked about this in many presentations that you find online, so I won't repeat that. But so that's really what sparked his thing. Like, okay, we need to stop this oligopoly. We need to build together. How can we basically build a decentralized version of this? And then that from that requirement came then, of course, the insight that the Web3 token would be perfect to achieve those goals.
There's a question in the Q&A asking what exactly is the role of the Impossible Cloud company within the Impossible Cloud network? Yeah. Because I mean, building something that is intended to be not centralized as the central player is sometimes a little bit tricky, and maybe you can elaborate on that a little bit, how the process is and what's the role of the company.
Yeah. So what the company, Impossible Cloud, the company does is it built a storage cloud service, which you see here on the left.
Yep.
And then it accesses the traditional Web 2 market through those market access tools and accesses those traditional Web 2 customers. So there it offers an S3 compatible cloud whose main competitors are Web 2 customers or Web 2 projects. But on the back end, we leverage that company is a customer of the Impossible Cloud network. They acquire hardware resources from the network and transact using the token to basically reserve capacity in the network and get access to storage. And so that model, you can scale that now to other companies, not Impossible Cloud, can use the token they have the same problem. I want GPUs in the Frankfurt area. How can I lease an NVIDIA H100 for 6 months in the Frankfurt area? Can I get a certain type of EC2 instance? That model, can I get a Hetzner node? Those kind of, everybody who's today getting Hetzner nodes or EC2 instances can instead use Impossible Cloud network to reserve similar kind of capacity in the future. That's the vision. And so the German company is just building an S3 implementation on top. But definitely, if other S3 competitors could also book capacity from the possible cloud network without any problem.
You mentioned Hetzner, and Hetzner is kind of competitor to AWS. Is Hetzner a competitor to Impossible Cloud, or is Hetzner possibly even a client in the form of a storage provider that is using your network? How is the how are the animals?
Yeah, so I think in the long run, Hetzner could be a potential hardware provider. So they could provide infrastructure into the network, and we would just be another way to book their capacity.
Okay. There comes another question, and I think we wanted to address the issue of how does it work with the validators and the tokens and so on. And a participant is asking, have you issued a token, and is it publicly tradable, or what purpose does it solve?
Yeah, indeed. So I think that's the next step. Where I was going to go next. Currently, the mainnet launch is coming soon, so it's planned for the near future. Today, we bootstrapped a part of the network, the Hypernode system, which are the validators. Those are running as of today. I have a slide on that, and so soon we'll list the token and then bootstrap the entire project. Let's see here.
And so what purpose does the token serve? What can I do with the token, or what?
So the token basically is a way to access the protocol, and so the token is used for the application and service layer here, which is all the
security identification.
It's a way of transacting. So if you lease hardware resources from the system, you reserve that by using the token, and then the token is also used by the participants to then pay out the hardware providers, and it's also used as a collateral function, because of course if you provide hardware and then people store a couple of petabytes in your system, we don't want you to disappear, right? And so next to the hardware contribution, there is also a strong collateral contribution that that's required. And maybe let me skip to that slide.
But you're currently using only one token, or are there different tokens for kind of purchasing something and governance and other?
No, so there's currently no token yet. So the token will be launched when we have the mainnet launch, and so there token is used for multiple things. One is incentivizing hardware to come on chain. So there is on the right hand side here, when hardware providers provide capacity, there is a incentivization to basically simply offering something to the network in the beginning phase is rewarded. And definitely also there's a protocol function there. Depending on the utilization, the reward is bigger. So if the object storage is full in the France region, then definitely we will incentivize more adding object storage servers in France and in Paris, for instance. Then there's a second here, which you see on the left-hand side. There's the capacity usage. So not only offering, but when effectively your server gets booked and then used, there's a second stream of rewards that flow from the protocol to the hardware providers, and that's based on usage. So you have the applications building on top. They pay every month for they reserve capacity in every month. Let's say, just like they do today with Hetzner, you pay every month to Hetzner. Here, you give the tokens to book the capacity for a month, and then basically you can access that hardware. The protocol then rewards the hardware providers for who have put that set of hardware on chain. And so that's how basically the flow there goes. Of course, part of that is also used in the second, let me go here, used in the second layer, or maybe the thing in the beginning was the most interesting part. So apart from the protocol itself, there is the hypernode system, which are really these out, which was the original question. Those are the core data verification components. And that's also where that community, people running it, will help secure the system so that it's a trustless environment. There's builders building applications on top. There's people contributing hardware. How do we guarantee that people actually provide the hardware that they promised? How can we prove that it's up? So all the data attestation, proof of availability, proof of location, and all kinds of other pluggable proofs, those run in that hypernode network.
But all these processes are kind of manual processes, or is that part of the network, the verification of the hardware and so on?
That's part of the network, and so these hypernodes are up and running, and they check the nodes, and they then basically paste the result of the verification to a satellite network where everybody can query the statistics, and then they of course also persist that in the blockchain in a hashed version, so that we have proof that what's in the satellite network is actually, you can basically go and check to see that data.
I see, yeah. There are a few questions in the Q&A. First one partly already addressed, but the question is, so how are the CPU, memory, and GPU resources used in the hypernodes and distributed? And how about bottlenecks? Are there bottlenecks in this structure?
So the hypernodes, in the hypernodes itself, is mainly checking. So the hardware network itself, which we call scalar nodes, this is what scales storage, what scales compute, what scales GPU. So those nodes, indeed, there's different types, different storage classes down the line, where you have, just like you have EC2 instances or types of Hetzner servers, that people can book a certain server, and of course that server then has the limitations of that hardware box. So so we're trying to also bring that up. That's part of the things that we verify. That effectively what you claim to have contributed is effectively what you contribute. And there's a ton of other projects which, in a point solution, have already addressed some of the challenges here. Like, how do you prove that a certain GPU has a certain capacity or a certain number of teraflops to compute? And so there's proof of computation to do those kind of things. So these kind of challenges are exactly those pluggable proofs that we think people building on top of the GPU stack will insert into the hypernode system.
Yeah. This somehow answers another question that has been asked, which is essentially, are you going to offer AI and IoT and other services in addition to just storage, and have other features and services offered by AWS?
Yeah. So yes, but we hope again that that's an ecosystem play, and that if we have to build all of those services one by one ourselves, it's going to take a long time. There's a ton of projects already, Web3 projects building in these spaces. And so all these Web3 projects and also Web2 projects could join, and hopefully they build Kafka as a service and Kubernetes as a service, infrastructure as a service on top of the hardware system. So really the core, the ICN network is really a way to book hardware capacity from a decentralized community of hardware providers, so that not all your data or not all your compute is running on one single provider, that you have guarantees there that these providers are isolated. They will not go down together. If you store your data across 3 different ones of them, it's not like if Google cancels your account, all your storage is gone, right? It was stored across multiple data centers, but you cannot access it anymore. And so here there's multiple providers, each offering each offering nodes. And if you want to build a multi-node data protection system, like we do for the object storage use case, you get nodes from different hardware providers, and you then basically store multiple fragments of the data spread across them.
I don't know if the slide answers the question, but can you disclose how large the network is already? So how many storage providers, how widespread it is globally, and so on? Is this something that you are open to disclose?
So I think currently we have quite many data centers in the Frankfurt area. That's really a hub there with multiple data centers. Then there's Poland, there's Amsterdam, and there's then I think Denmark and US East Coast, and I think UK, US West Coast, and Asia are in the near-term roadmap. And so it's one, geographically adding more and more regions, and then two, of course, increasing the types of hardware.
Right. There are two more questions. One is very easy. Just asking, do you see yourself as the first B2B blockchain provider? I think you mentioned it a little bit, that in the deep-in space, many others that don't attract large client businesses, right?
Yeah. I think we're probably the ones who are building the bridge starting from the Web 2 side. Is that we want to build a bridge from the customers into the use case, and we will leverage any strengths of Web 3 that we can in the places where that's available. But we want to stay competitive with our Web 2 competitors. So, for instance, performance, we cannot store the data, core data in the blockchain today. The speed is not there to do that in less than 100 milliseconds, which is what you get on Amazon S3. So there we use a combination of Web 2 and Web 3 technology, Web 3 where we can, but we want to keep on matching the quality and performance of Web 2. Of course, that's for the storage use case. Anybody else can build on top of Impossible Cloud Network, get hardware, and do whatever they want, right? That's simply how we, as Impossible Cloud, the German company, build on top of the network. Other people can build on top of the network in a different way.
All right. There's a further question which a little bit goes into the direction financing, and as I mentioned earlier, we have just bought some of the tokens. But Thomas is asking, how are tokens assigned to participants? Do they come directly from the network customers, or do you consistently mint new tokens? But maybe you can even describe briefly your most recent token distribution or token sale.
Yeah, so there. So I think there's a lot of detail of the tokenomics on our website. So I think there I'll show it later. We can go into great detail. We minted about 700 million tokens. There, that will start circulating whenever we launch in mainnet. So there, then people who have unlocked tokens can start using them. And of course, people booking capacity need tokens to basically reserve capacity in the network, and then that will distribute to the hardware providers. There's also the collateral requirements, and that's where the node sale comes in. So apart from the token, there's also ICN Link, which is an NFT, which represent basically an unlock of tokens over time. And that's there to allow people to run hypernodes or to be used to help hardware providers collateralize. So next to the hardware, they also need to put up collateral in case they would disappear, that the network can repair the data, get it from somewhere else, recreate it, store it somewhere else. Of course, there's a network and storage cost to that. And so if people would leave the network while they have active contracts running or active service booked, then the collateral related to those servers would be slashed and would be used then to give to the protocol, so that the protocol can basically use that repair function and also potentially reimburse the users that got affected. So, and the ICN link there is an NFT that can be used in 2 ways: one, to run a hypernode, or two, to help put up collateral. So people can stake their NFT with one of the hardware providers, and then basically they can co-earn. So by helping the hardware provider put up collateral, you then also get a part of the tokens that are awarded to that hardware provider every month when their servers get booked. So it's also an ecosystem development thing here, where hardware providers don't need to put up all the collateral investment themselves. That's a community thing where people can help, and then if they help, they also get rewarded, and that's again a big difference with Web 2, where basically all of the investment, but also all of the proceeds go to this one single party that's trying to always eat up more and more and more of the pie and push out the other participants.
I think this is a quite innovative way to, and I mean, if I understand correctly, it was partly intended to be to contribute to the financing, that you kind of sell token that, or NFTs in this particular case, that represent the right to run a node in the network, which translates a little bit if McDonald's would sell tokens that represent the right to run a McDonald's restaurant, a franchise restaurant at a specific place or whatever. I think that's quite a smart move, and frankly speaking, I haven't heard of any token or NFT sale projects where this kind of right is associated or is given to the token holders. I don't know if you have seen other projects, but when I came across this I said, hey, these guys are smart, not only in terms of how this is technically set up, but also the way to kind of distribute the participation rights in the network.
Yeah, so definitely there are other projects who have taken this approach of the node sale to bootstrap part of the network. It's indeed it achieves multiple goals at once. You build a community. There's people who have a shared reason for the protocol to be successful, and to build it together for a couple of years, and really to bootstrap the network. This is a very strong incentive for people to join and to build and stay around for a couple of years to really bootstrap this network from where it is today to a true global network.
Yeah. Can you say how many NFTs have been sold, or how many tokens have been sold in this thing? I think it's disclosed on your website, but
yeah, I think for the node sale, I think there were 55,000 NFTs that were originally available, and I think most of them, the majority of them, have been sold. I don't know the number by heart, and so I don't want to.
Yeah.
I want to make sure that I don't give the wrong number.
Yeah, but I heard something, and I think it was quite an impressive number indeed. Yeah, very cool. We are approaching the intended end of talk, and I don't know if there are any further questions in the Q&A. And yeah, there are 2 more questions. Yeah, I was going to ask, how about redundancy of storage? How many instances are stored? And Berthold is asking, can you walk us through a worst case scenario, like a coordinated attack on the hypernodes? Do you have scenarios for this?
So I think maybe the first question, that's of course completely up to the project building on top, right? Impossible Cloud Network is just by itself a way to acquire hardware resources. So if you look at the screen right now, you see, okay, this is a node in EMEA. This is the uptime over the last 30 days on the left-hand side. And then on the right, you see how collateralized it is, that you can get the guarantee that there's enough collateral there that if this node would, for whatever reason, be taken down by the hardware provider, that the protocol has already sufficient funds to then pay for the repair actions. Of course, as a builder on top, you need to protect your system across multiple of these hardware nodes, right? Because it's different for every system. Some people will want to make 3 copies of the data. Other people will want to erase your code, the data across multiple different servers. For compute, you probably don't want to run your compute twice. For compute, you want to just restart it somewhere else. So it's really dependent on the builder, the project building on top, how they then protect the data. So that's not part of the of ICN, the network.
Yep.
But with Impossible Cloud, what we do is we book multiple servers, and so we protect the data across different devices on different servers from different hardware providers, so that we also get device failure protection, node failure protection, and then eventually also we want differentiation between the different hardware providers and data centers running running parts of the system, so that if a data center is unavailable, we can then recover from the other data.
How about this worst case scenario? Can you elaborate a little bit on that?
So in the hypernodes, as any validator system, and that's also why this node sale and getting many licenses out there was important. Definitely, they basically validate state of the system, but there is always a way to basically for the hardware provider to appeal, right? So if there's a claim made that, hey, you're down, there is a mechanism in place to basically appeal and say, I can prove that I was not down. So it's a combination, the hypernode network, and that's today still a manual process. So I think bootstrapping this decentralized cloud, we don't have all the answers from day one. I think the hypernode networks check, they post on chain their results, and then slashing in the first version of the system, slashing will not be automatic. Slashing will go through the foundation, and so the foundation, the operator of the network, will then check in with the hardware provider and basically see if they agree or if they want to appeal the decision, and if they have any evidence to bring for that appeal. Over time, of course, we hope to make this more and more automatic and decentralized, and eventually bake it into the protocol itself. But on day one, we don't have a foolproof solution to doing that, and so we wanted to protect the system by having here still the operator, the foundation in the loop, to be the arbiter here.
Okay, there's one more question. It states, how do you check the data availability? Do you check if the storage provider actually stores the data it should store? And are you going to have the same approach than Ethereum research team with this collateral and slashing approach?
Yeah. So indeed, there's many other projects already doing something similar, and it's also where the pluggable proofs come in. Any project building on top of ICN can choose their own way of what validation that they want for their hardware classes. And on the storage system, on the storage layer, there's a ton of projects who already have something like proof of storage, where you say, okay, give me the hash of byte 1000 to 2000 of this file, and then basically if the hardware provider can produce that hash, then you assume that they have durably stored the data.
All right.
And so similar systems. And again, for every builder, for every application, the type of proof will be different. And so that's why also the proofs will need to be pluggable, and projects can input a proof that works for them.
Cool, thank you very much. We have come to the end of our intended slot, and yeah, once again, I think it's a pretty interesting thing. I'm very, very happy to having had the opportunity to dig a little bit deeper than I already had it, and yeah, wishing you and the team all the best success. And I'm very happy that this project is not only pretty innovative, but it's located in Hamburg to hopefully help Hamburg to become even more prominent as a top location for cool blockchain or decentralized topics and projects. All right, Thomas, wishing you a wonderful evening. Thank you very much. And dear attendees, thanks for being with us and for your questions.
Yeah, thanks a lot for making it interactive. That's always way more fun. I'll be in Hamburg next week, so let's build a decentralized Web3 community in Hamburg. That's great. Thanks a lot, and thanks everybody for dialing in.
Perfect. Tschüss.